the realistic simulations, the physics, and the rendering in Omniverse, I wanted to create this virtual puppet. I ended up using Arduino so I could do real-time streaming between an IMU and our virtual puppet here. In the video, I'm going to go over how I did it. I started with an Arduino script. It uses the RP2040 for Arduino, and it streams on UDP. So here's just an example of uploading the code. This is the Arduino Nano on the right side, and then the plot is the IMU graph data on the left side. So it's a pretty straightforward process. This UDP data gets streamed to Python. It's a really basic Python script, only a few lines that needs to receive the data. The main thing is the UDP port, which I have assigned as 8882 on this Arduino. But then you can assign multiple different ports on different Arduinos. So using 2 different Arduinos, I can receive one message on one, and when I switch out the Arduino for another one, I start receiving message 2. This becomes useful later if you would want to create like 2 different puppets. You could have 2 different Arduinos that are both receiving the different messages together, or you can have 2 Arduinos sending to the same script itself and just parse them based on the message. So here's in the scene, the general way that it works. I used all the assets from the physics demo scenes that already come with NVIDIA assets. There's this humanoid character that I put a couple basic colliders on. Then within each of the joints, I redid every joint. So there's a spherical joint on the humanoid. It has some range and limits. And one of the other connections is to the link. These links come from the rigid body rope demo in the physics system, and I just duplicated a bunch of them. At the top, I connected that rope link as a fixed joint to this little armature that I've created. It's just 2 cylinders in a box. Each of those, the leg bar and the hand bar and the central bar, all connect to either the head or the legs or the hand. They're all connected with this controller. The important part of the script is this controller. The xform of the controller has a Python scripting component, which is these behavior scripts. They attach to the xform and whenever the play button is run, they let that object start running. So you see here, this puppet is on UDP port 8882. And that means on my puppet handle 2 script, I'm able to pull in the data. So on the play, I set up my port, I set the binding to that socket, and I set it as a non-blocking port. So on every update, so every tick of the animation or the play, I get the data. The first challenge is just clearing the buffers so that things don't get blocked up in the socket. Once we've cleared it, we know what the last piece of data we had was, so we can return that. If it's no data there, then we just don't care. And if there is, then we can decode it. We split up the IMU data by the X, Y, and Z, just called it a roll, yaw, and pitch. And I give a little offset for the pitch. And we set the xform of the attribute for that primitive. And that's it. So we're just directly streaming in the data. And I have another puppet handler, number 1, and that has 8881 as the UDP port. All right, so the whole script is this maybe 100 lines of code, less 75 lines of code. A lot of it is boilerplate code. And at the end, we press play, the physics turn on, and the puppet connects. And on the bottom right, you can see I pick up this little AA battery pack that I have connected to the Arduino, and I can move it around. And it's pretty responsive, basically real time. It's running at 30 frames a second. And each frame is taking around 30 milliseconds to calculate. So I try to make it dance a little bit, had a little fun. It's a fun project to do. It only took a day or 2 to set up in its entirety. You could use this for pretty much any data you want, connecting to the Arduino, putting different sensors like potentiometers and all that fun stuff. So I hope you enjoy. Everything will be online and available to download.